Hello everybody. In this session, initially we will understand what are the different fields within an instruction, after which we will completely get into the instruction cycle, how fetch, decode and the execution phases will happen. Okay, now let us have a look at the instruction. Once again, remember that the main memory size is equal to 4096 words, which each word is of 16 bits, meaning one data word or one instruction size must be equal to 16 digits. An address within the main memory should also be equal to 12 digits. That is, 4096 is equal to 12 digits. That is, 2 power 12 is equal to 4096. That means that one address must be equal to 12 digits. One data word should be equal to 12 digits. Sorry, 16 digits. This data word could either be an instruction or it could be data operand. Okay. Now it is quite clear that our instruction size is equal to 16 digits because one word in the main memory is equal to 16 digits, right? One word in the main memory is equal to 16 digits. Hence, our instruction register size should also be equal to 16 because the instruction size would obviously be equal to 16 digit because it has to be 16 digit because one word in the main memory will always be equal to 16 digits. If you could digest this, then we are all set to understand the different fields in the instruction. Now, if you want to understand the different fields in the instruction, first of all, the thing is, this instruction is of two parts primarily. That is, one part is address of the operand. Second part is opcode. Okay. So initially, you can understand that this instruction will have two fields. One is opcode and one more is address part of an operand. Okay. Now forget about this address part of an operand. Let us understand what is one address size. One address size is equal to 12 digits, right? Yes or no? One address is equal to 12 digits. So in an instruction, there will be an address all the time. One field is always an address. What is this address? We'll understand later. Understand that this instruction has two fields. One field will hold a memory address and the additional field is called opcode field. Total is equal to 16, right? Once again, instruction is divided into two fields. One field is the address field, which is always going to specify one memory address. What it is we'll understand later, but understand that this address field should be equal to 12 digits because one memory address is equal to 12 digits. So 16 minus 12 will be equal to 4, right? So opcode field is equal to 4 bits and the address field is equal to 12 digits. So initially the instruction can be broken up into these two fields. One opcode field which is of 4 digits and one address field which is of 12 digits. This is my initial instruction with 4-digit opcode which specifies one operation and with 12-digit memory address. What is this 12-digit memory address? Let us understand precisely. Now here, let us say that the 4-digit opcode is, let us say, add. Understand that the opcode field is specifying one operation, that is add. For specifying this add operation, I do require 4 bits because opcode is equal to 4. Okay. We will come to this part later. Now you understand that the first 4-bit opcode is just nothing but addition. Okay. This addition is followed by a 12-digit address. This 12-digit address decimal equivalent is, let us say, 240. Okay. So finally, the instruction is simply, if you write it in simple words, it is add 240. Now understand, this add is of 4 bits. some binary equivalent of 4 will be matched to this add. Forget about this. This add, this opcode has an address field within the instruction. What is this address field? This address field is going to specify a memory address. That is, you go to main memory. Taking this address, you need to go to the main memory. Under a main memory location 240, there is one operand. That is, let us say 100. Okay. So this add 240 is actually equal to accumulator plus memory of 240. This is the actual meaning of add 240. We have already discussed that every instruction is going to hold one operand, right? Every instruction is going to specify one operand. And the other operand for every instruction is always accumulator, right? This is the reason why the instruction holds only one operand in the form of a memory address. So look at every instruction. For every instruction, the initial part, the first 4 bits are going to specify the opcode. The opcode, let us say in this case, we are thinking that it is addition. Opcode is just nothing but addition. Followed by the second field is the address part of the operand. The address part of the instruction, which is going to specify a memory address in which the operand is available. So here in our case, it is 240. So going to 240, you will get the actual operand. So finally, accumulator will be equal to accumulator plus 240. Okay. So this is how instruction is actually designed. Instruction is of 2 fields. One is opcode field and one more is address of the operand, which is actually holding a memory address in which the actual operand is available. Finally, the operation is accumulator. Since the accumulator is always the implied operand, by default operand for every instruction, second operand will be available in the main memory. This memory address is specified within the instruction. So add 240 meaning accumulator plus m of 240. M of 240 is 100. So if the accumulator value is equal to 100, 100 plus 100 will be equal to accumulator value. This is how the instruction is designed. Now let me add one more field to the instruction. Initially, we thought, we conceived that the instruction is of 2 fields. One is opcode. Opcode is of 4 bits. Plus one more is address part of the operand. That is address of operand, which is of 12 digits. Because one address is always equal to 12 digits, we can't help it. There has to be 12 digits in the instruction should always be given to the address part of the operand. By using the remaining digits, we can specify an opcode. Now, I am going to go to the next level of designing this instruction. Actually, every instruction in any computer system is of 3 fields. One is mode field, second one is opcode field, and the third one is address of the operand. Address of the operand. This address of the operand is anyhow 12 digits. Now, in addition to these 12 digits, we just have got 4 digits. These 4 digits, I am dividing it to 2 fields again. That is, the first bit I am giving to the mode digit. Next 3 digits are the opcode digits. Sir, what is this mode? We have just heard about opcode. We did not hear about the mode at all. Don't worry. Let me explain you. Let us have a look at the instruction once again. Every instruction's first bit will specify a mode. This mode digit, as it is a single digit, it can be either 0 or 1, right? Followed by the operation. In our case, we are thinking that the operation is addition. The opcode is, we are assuming that it is addition, followed by an address of the operand, right? So now, anyhow, you know that this is the address of the operand, taking which you need to go to the main memory. Under that specific main memory location, you got the operand, and this must be added to the accumulator. Okay. Now, what is this mode digit? This mode digit can also be called as an addressing mode. The first digit can be called as a mode digit or an addressing mode digit. What is this addressing mode? Try to understand. This mode digit will actually talk about this address. If the mode digit is 0, then the address is a direct address. If the mode digit is equal to 1, then the address is an indirect address. What is direct address and what is an indirect address? If the mode digit is equal to a 0, then this address is a direct address in which the actual operand is available. We already knew it. But when the mode digit is 1, that means that this address holds another address. That is, inside this specific address, we do not have the operand. Rather, under that address, we have one more address. In that address of the main memory, we got the operand. Let us say this might be 50. This is the difference between direct addressing mode and an indirect addressing mode. Once again, the instruction will have 3 fields. The first digit is always mode digit. It could be either 0 or 1. 0 is for direct addressing, 1 is for indirect addressing. Next 3 digits are the opcode digits. Okay, so there might be from 000 to 111. There are a total of 8 opcodes are available within the system. Each combination is decoded to one specific operation. For an example, 000 is, let us say, addition. Okay, every time if you have a look at the opcode, and if the value of the opcode is 000, then it is nothing but addition operation. Okay, forget about it. Let us be assuming again, in our computer system, opcode bits is equal to 3 digits, and we are assuming that 000 is equal to addition. But generally, it depends on the opcode size in each and every processor. Different opcode combinations are encoded to different operations. Okay, now here in this case, we are imagining that 000 is equal to addition. Finally, this address of the operand is a memory address under which the actual operand is stored and located, right? So now, once again, you have a look at the 0 and 1. 0 specifies direct address, 1 specifies indirect address. 0, add 240. What does it mean? Accumulator is equal to accumulator plus memory of 240, which means that at a 240th location, there is a value. That value needed to be added to the accumulator. But if it is 1 added 240, this 1 is for indirect addressing mode. Indirect addressing mode specifies that the address of an instruction is going to hold another address in which the actual operand is available. Okay, so at that case, accumulator is equal to accumulator plus m of 240. Okay, here is m of the 240 is equal to m of 240 is equal to 100, and m of 240 is equal to m of 100 is equal to 50. Finally, 50 must be added to accumulator in order to get the output which gets stored into accumulator. Only one and only one thing that is needed to be understood at this point of period while you understanding about the design of the instruction. The first bit will always specify the addressing mode. If the mode digit is equal to a 0, the address part of the instruction is going to hold an address in which there is an operand. If the mode digit is equal to a 1, then the address part of the instruction is going to hold another address which holds the actual operand. Okay, so this is how mode actually does work. Thank you. In the next session, we completely understand about the instruction cycle.